So in a previous video, we talked about using Windows Task Manager to begin looking for performance-related issues. And I made allusion to the fact that there are some things that I think are kind of important that are missing. Now, there is another tool, there's actually two other tools that we can use to track Windows performance issues. In this one, we're going to focus on Resource Monitor, which I think is a step up above Windows Task Manager. So I'm going to search for Resource Monitor. And again, I'm doing this on my Windows 11 system because, well, frankly, there's going to be more things going on, so it's going to be more fun to look at. All right, let me start with my overview screen and not CPU. Okay, on my overview screen here, I'm going to see CPU, disk, network, and memory. And if I expand those, it's going to show me applications that are using that. We're going to see graphs over here for CPU, disk, network, and memory. And then we're going to see some other statistics here, but I want to look at them on a object by object basis. So let's start with CPU. Now, CPU, this is going to give me, over the last 60 seconds, it's going to give me my CPU total usage. Now, I have multiple CPUs on here, right? And since I have virtualization, I've basically got 12 virtual cores that we're using. So this is going to be my total. This is going to be the amount of CPU usage that's dedicated to services. And then it's going to show me on a CPU by CPU basis. CPU 0, 1, 2, 3, 4. And each one of these is going to be a virtual core. Okay. Here we're going to see our processes, their status, how many threads they have, how much CPU time they're using. And by clicking on this, any of these columns, I can sort by that column. Average CPU is going to tell me over the past few minutes. The Panopto recorder is averaging 21.9% of my CPU time, which makes sense because that's what I'm using to record this video. Now, this is my processes. I can also view this for services, for associated handles, or for associated modules. So if my CPU seems like it's running abnormally high, then this is where I can come in to explore that. Remember, total CPU usage, amount for Windows services, and then individual CPU cores. You may run into a situation, by the way, where you see a CPU core that is maxed out and is not changing. That normally is a process that has run amok, and we need to find the process running on that CPU core and kill it. All right, let's take a look at memory. So this is going to give me a little more memory or a little more information on my memory than I had before. So again, here it's going to be processes that are using memory, the image, the process ID, the committed memory, the working memory. Okay, there's one here, hard false. You'll see it here and you'll see it here. This, I think, is one of the most useful memory statistics. Now, hard false means the system went looking for something in memory, could not find it, and had to go back to the hard drive to get the information. Now, that could be for a couple of different reasons. Number one, it could be because I don't have enough memory, physical memory, and so I'm having to swap out quite a bit. That could be a problem that could slow my system down. The other thing might just be that I'm loading a new application. So I'm going to do something here and we're going to see if this does what I want it to. I'm going to load up Microsoft Word. And when I did, we saw a couple of little bumps there and hard faults. Not a whole lot, just a little bit. Just enough to say, hey, we did have to run out. And because I just opened a new application, we had to go find that information. You can barely see them there. Yeah, it's not even showing them up here at the moment. So it could be that we're just doing a lot of loading. And if that's the case, then that may not be a memory issue. It might be a, hey, we might be slowing down because we're opening lots of data or applications, so we might just want to speed up our hard drives through dividing things out to multiple physical devices or RAID or whatever, or even faster physical devices. Okay. So that's hard faults. I think this is an incredibly useful thing to be able to look at. If your system is generating a lot of them, we have a problem. Commit charge, this is how much I've committed, my used physical memory. Here, this actually kind of freaks people out sometimes because we look at this and we say, all right, I think I've got 48 gigs of memory in this thing, and I only have 1.7 gig free. What the heck? All right, this isn't as bad as it looks like. So we have some hardware reserved memory. This is memory that's actively in use. So this is key. We have to have this modified memory. This contains information that has been changed in memory but has not yet been written to disk. So before we clear this, it has to be written. Now this here in standby memory, a lot of this is cached. So it's information. In fact, if you look at this, available 21 gigs, free 1.7. What the heck? The difference is available is a combination of your standby and your free. So don't panic if this number looks slower than you think it is, because standby is stuff basically we have in memory just in case we need it. But if we don't need it, we can drop it in a heartbeat and use that memory for something else. This I can't drop unless I close applications. This I can't drop until I save it. This I can drop in a second. So also be aware that you can change your views, large, medium, and small. Okay, let's look at disk. So disk, this is going to show us our processes with its activity. Here's disk activity, most of this being done by the system, and here's my available storage. Okay, statistics over here. So this is my percentage, or my disk transfer rate. So we see that we're reading and writing from disk here. Again, I'm recording a video, go figure, of course we should be. This is on a scale of 0 to 10 megabits per second. Okay, useful, but I think these are more useful. This is my disk queue length, and I've got one for the D drive and one for the C drive. Now, my disk queue length. A queue happens when I have processes that are trying to access the disk subsystem and they can't. Now, again, there's something here that I don't like because this looks like, oh, I've got consistent disk queue length. Here it looks like, okay, I've got consistent disk queues. This is a problem. But if you look at the scale, this is from 0 to 0.05. This is from 0 to 0.01. Okay, that's not really a problem. I think the raw numbers here are actually a little more helpful. In fact, here you can see these raw numbers. What you're looking for here, the bigger your disk queue, the more applications are waiting for access to the disk, either to read or write, which means they're sitting there doing nothing. They're waiting to be able to access the disk so they can get on with their life, which means the user is waiting. So I think that disk queue length is really important. Now, what do you do if the disk queue length is high? And I'm going to say, and different people have different perspectives on this, I'm going to say a disk queue length on average of greater than 2 might be a problem. So if you notice your disk queue length is high, then what you're going to have to do is figure out how to speed up read and write applications. And typically that involves adding more disks. So if I have one physical disk, in this case I've got 2. But let's say I have this one here that I'm running a disk queue length, and disk C, obviously my operating system drive. So let's say I'm having a bunch of programs queued up trying to access disk C. Maybe I move some things off to disk D. Or maybe I add another disk and move some things off to there. Or maybe I take out my C drive and I put in a RAID with 4 drives so that writes can be split across all 4, reads and writes can be split across all 4 rather than 1. Maybe I take out a spinning drive and add an SSD or an NVMe, something like that, so that I can process these requests faster. Either divide them up into multiple lines or process them faster. Think of it like a checkout line at Walmart, right? We got a bunch of people lined up behind one cashier. We got 2 options. We can add more cashiers or we can make the cashier go faster. All right, it's kind of what we're doing. And then network. And again, we have processes with network activity. Let's view my overall network activity. Let's look at my TCP connections. These are current active connections. And then listening ports are applications I have that are listening for some kind of outside connection. Here I have my network activity, my TCP connections, and then I've got a couple of different virtual switches here. Again, look at the scale because this looks massive, right? I'm having huge spikes of network traffic, but that's actually from 0 to, in this case, 10 kilobits. So that's actually not nearly as bad as it looks. So make sure you always take the scale into account. And then TCP connections, again, 0 to 100. You're going to have some active TCP connections if you are on a network. Okay. There we go. That is Resource Monitor. Now, Resource Monitor gives me some statistics that Task Manager does not. I will normally, if I'm troubleshooting a performance issue, start with Task Manager. If that doesn't give me the information I need, I will go to Resource Monitor. Now, Resource Monitor actually ties into a third application, which is Performance Monitor. That's the big one, and that's what we're going to look at in our next video.